This is problem 107 of Neetcode 150, maximum product subarray. So we're going to be given an array of integers, and we're going to have to find the subarray that contains the largest product. And we're also going to have to return this largest product. So if we take a look at this example 1, we have 1, 2, minus 3, and 4. So notice that we cannot multiply two numbers that are not adjacent to one another. So we can't take like 2 multiplied with 4 and just return 8 as the output because they are not adjacent. Numbers that are adjacent are 1 and 2. So you can do 1 times 2 and it's 2, right? So from there, we can see that the maximum is 2. The next number is negative 3. So if you multiply negative 3 by 2, you're going to have negative 6. But negative 6 is not greater than what you previously had, which was 2. And then you have 4. So you have 4, and you can do 4 times negative 6, or you can do 4 times negative 3. So at this point, you're going to have a negative value as well, and it's going to be greater than it's going to be lesser than the previous value of 2 that you reach. But a good thing is that you can take a value and multiply it. Basically, you can just like return 4 raised to the 1. So 4 itself can be returned. So this is why you can see the output is 4, because the number itself can be an answer. In example 2, we have basically negative 2 and we have negative 1. So each number could be returned by themselves. And if this was if the problem has basically to return a single number, we will have to return -1 because it is the greatest between both. But now we can multiply them, and two negative numbers are going to give birth to a positive numbers. So to start this problem, I will show you a brute force approach, and then I will give you the dynamic programming solution that actually solved this in a much better time and space complexity. So the brute force approach is going to go see every single numbers, and it's going to multiply it by all the other numbers. So if we have basically these, so 2, 4, negative 3, negative 2, and 7, what we're going to do is that we're going to go for 2, and we're going to multiply it by the next number. So now we're at 8. Now we're going to go multiply this by the next number. So now we're at negative 24. And every time that we multiply something, we just want to compare what is the previous greatest value. So let's say we have r that, well, now it's going to be 8, right? Because 8 is the greatest value we've seen so far. So every time we want to compare the new value with the greatest value, is 24 greater than 8? No. So we're just going to keep going. And now we're going to have 24 times negative 2. So we're going to have a positive number again, 48. And this time, yes, 48 is greater than our previous 8. So we're going to update our greatest value. And then we're going to do 48 times 7, which is 236. And 236 is greater than our 48. So we definitely know that we could stop here, but in a brute force algorithm, we're actually going to do the same thing for all the other numbers. So we're going to start from 4, and we're going to do the exact same process. So we're going to start at 4, and we're going to check if 4 is greater than the previous greatest number, which is still 336. No. So we're just going to multiply 4 by the next number, which is negative 3. So we're going to have negative 12. And we're going to do then negative 12 times negative 2. So we're going to have 24. And we're also going to check if 24 is greater than the previous greatest value, and on and on. And then at the end, we're going to realize that 336 is the greatest value we encounter in this entire string, and in this entire array, pardon me. So let's go ahead and code this. This is not the most important part of the problem. I just want to show you what a brute force approach will be. So first, we want to create, we want to set the results to be the very first value in the index, just to start. So results is going to be equal to the number 0. And now we're going to go for every single number. So I will say for I in the range of the len of nums. And what I will do is that I will basically create a current that will be equal to that particular number at this particular index. Okay, and what I will be willing to do after this is to also set a temporary variable. So let me call this temp, which is going to be equal to the current. Or I don't even have to do this. What I have to do is that I will just then go for all the other values. I will say for g in the range of I plus 1 up to the len of nums. What I will do is that I will say that the current, well, I will hold a temporary variable, current, and basically on each number, I want to take that temporary variable and multiply this by the number that we have. So it's going to be nums at the index g. And then I want to set the current to be equal to the maximum value between the previous current and also the temporary variable. And at the end of this, we want to set the result to be equal to the greatest value between the previous results and that current. So we're going to go for every single numbers, and for every single numbers, we're just going to figure out what is the greatest what is the greatest product it can have with the other numbers. So that is the very brute force approach, where we go for every numbers, and for every numbers we go for every single other numbers, and at the end we are going to return the results. So let's test this out. So this works just fine, but we can do better, and I think the problem itself is asking us to have a time complexity of big of n and a space of big of 1, but this has a basically a times complexity of big of n squared. So let's actually figure out how we can use dynamic programmation to do better. So let's just pull up the whiteboard first. So the strategy to do better is going to be to keep track of the current minimum value and the current greatest value at every single instant, and it's going to start at 1 for each. So the minimum will be 1 and the maximum will be 1. All right. And now when we go to 2, we're basically going to set the minimum and the current maximum to be the greatest the value in the smallest value that we can have at this really place. So we know that at 2 we're just going to have basically 2 and 2. These are going to be greatest and maximum value because we can't get anything else from that. And now once we go to 4, we're also going to have we're going to have a minimum value of 2, and we're going to have a maximum value of 8. And you might not realize why this is important, but it will become important once we get negative values. So just here. So notice that when we do basically when we go to the next, we have -3. So the minimum value will be negative 24, right? And the maximum value, well, it's still going to be 8. So this is quite important because take a look at this. We go see then -2. And now when we multiply the minimum value and the maximum value by -2, well, see what happened. The minimum value will become -16, right? And it's going to be, well, the result of -2 times 8. But the maximum value is going to be basically that minimum value that we get here times that -2, right? So it's going to be 48. So this is basically how we account for negative values inside our list. Um, and then we have 7, which I think the rest is just stating the obvious at this point. So you're gonna have like negative 112 and 336. And finally, you're just going to return that greatest value here, 336, and that's going to be your result. So that's really the entire solution to basically solve this in big O of n, because we're going to go once through every single values, and you're just going to keep track of the minimum value you can get so far, the maximum value, and the goal of that is just that we know that the minimum value, which can possibly be negative, might gonna end up becoming the greatest value if we reach another number that is negative as well. So just like in this example, when we reach the negative 2 and we multiply negative 2 by our min max, or the maximum minimum, which became 48. So this is how we solve this problem. And with that being said, let's actually code this. So first thing that we want to do, once again, is that we're going to set the results to be equal to that first number inside the nums array. And then I'm going to create a current minimum and a current maximum. And I will initially set both equal to 1, which is logic, because if we set them equal to 0, well, we will get 0 all the time, right? So we need something like 1 that does not affect the product, but that so that's like the most neutral value we can get. And then we're going to go for every single value, right? So for n in nums, and I will just set my current max to be equal to the maximum of something, and I will set again my current min to be equal to the minimum of something. So what is the current max going to be equal to? So basically, it's going to be equal to the maximum between that n value that we have times the current max. We can also have the current number we have times the current min. And we can also have the number itself. And reason is that, let's say that we encounter a 0 inside the array. Well, the cure max and the cure min will be set to 0 at this very point. So if like if the number after 0 it's like 10, for example, well, once we reach 10, well, we're gonna have still a cure max and a cure min of 0, but we're gonna be willing to set that value of n to be the cure max and the cure min. So they're not giving any example, but I think you can see the reason why. Also notice that cure max here, well, the cure min is basically going to be the minimum of these same values. But notice that the cure max here is actually going to be modified here, right? Because the cure max is going to be the maximum between these three values. So it might not be the same as what it used to be. So just in order to keep what it used to be, I will just set a temporary variable, which is going to be equal to the cure max times n. And I will replace this like that, all right? And after this, I want to ensure that the result is going to be the maximum value between the current results and the cure max at that very point, all right? So that's the entire algorithm. We can now return the results, and this is going to give us the greatest value. So there you go. Awesome. So I hope you learned from this video, and I hope to see you in the next one.